Now, let us consider one more problem. Find the equation of the plane that contains the point 1, minus 1, 2 and is perpendicular to each of the planes. 2x plus 3y minus 2z is equal to 5 and x plus 2y minus 3z is equal to 8. So, the required plane is perpendicular to these two planes as well as passing through 1, minus 1, 2. What is that equation of the plane? So, generally the equation of a plane which passes through some given point x1, y1, z1 in Cartesian form is some a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. Now, we can take that Cartesian form here. The Cartesian equation of the plane passing through Cartesian equation of the plane passing through 1, minus 1, 2 is some a into x minus 1, b into y plus 1 plus c into z minus 2 is equal to 0, where a comma b comma c are drs of normal of the plane. Direction cosines to normal of the plane. Now, this is the Cartesian equation of a plane and this plane is perpendicular to each of the given two planes. But given that this plane, let it be 1. Now, given that 1 is perpendicular to 2x plus 3y minus 2z is equal to 5 and also x plus 2y minus 3z is equal to 8. Now, therefore, so here the direction ratios of normals of this plane are ABC, and what are the direction ratios of normals to this plane? 2, 3, minus 2. When these two planes are perpendicular to each other, then A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So, we have that property, we have that formula. Now, using that formula, we can write it as A into 2, 2A, B into 3, 3B, C into minus 2, minus 2C is equal to 0. Let it be second one. And this plane is also perpendicular to this one, so that the direction ratios in this plane are ABC and direction ratios to the normal of this plane are 1, 2, minus 3, and again apply the same formula here. A into 1 A, B into 2 2B plus C into minus 3 minus 3C is equal to 0. Let it be third. Now, solve these two equations. So, actually here there are 3 unknown quantities with 2 equations. So, we cannot get ABC values directly. Here we can get the proportionate values of ABC. Now, let us solve them. Here, eliminate any one of ABC. I am going to eliminate A here. So, multiplying the third equation with the 2 and subtract from second equation. 2 minus 2 into 3, that is 2A plus 3B minus 2C is equal to 0, and multiply third equation with the 2, 2A plus 4B minus 6C is equal to 0. Now, subtract them. It is minus minus plus. Now, both gets cancelled. Minus B And what about this? Minus 2c plus 6c plus 4c is equal to 0. Therefore, b is equal to 4c. Now, substitute that b value in either second equation or third equation, whatever that. But I am going to substitute that b in third equation. From 3, a plus 2b, 2 into 4c, that is 8c minus 3c is equal to 0. Therefore, a plus 5c 0 or a equal to minus 5c. So that we find a and b both are in terms of c. Now substitute them in the first equation. From the first equation, a is equal to minus 5c into x minus 1 and b in terms of c. What is that? 4c into y plus 1 and c remains same, c into z minus 2 is equal to 0. You know clearly c gets cancelled completely in the equation. So after cancel that c, now it changes to minus 5 into x minus 1 plus 4 into y plus 1 plus z minus 2 is equal to 0. Right now this is minus 5x plus 4y plus z. This is plus 5 plus 4 plus 9 minus 2 plus 7 is equal to 0. And multiplying this entire equation with minus. So 5x minus 4y minus z minus 7 is equal to 0. What is this? It is equation of the plane passing through given point and is perpendicular to given planes. Find the distance between the point 6, 5, 9 and the plane determined by the points A, 3, minus 1, 2, B, 5, 2, 4, C, minus 1, 6. Now a plane is determined by the 3 points. Here A, B, C are 3 points and P is the point whose coordinates are 6, 5, 9 outside of the plane. Now we have to find the perpendicular distance from the point to the plane. For this, we have to find equation of the plane first. What is the Cartesian equation of the plane? The equation of plane determined by the points A, B, C. Determine the points A, B, C is determinant of x minus x1, y minus y1, z minus z1. And second row, x2 minus x1, y2 minus y1, z2 minus z1. And x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. Now this is the Cartesian equation of the plane determined by the 3 points x1, y1, z1, x2, y2, z2 and x3, y3, z3. Here the 3 points are given. That means x1, y1, z1, x2, y2, z2, x3, y3, z3 are given. Now substitute them here directly. That is x minus, where x1 is equal to 3, y minus, y1 is equal to minus 1, it is minus of minus plus 1, z minus, z1 is equal to 2 by x2 minus x1, 5 minus 3 and 2 minus of minus plus 1, 4 minus 2, x3 minus x1, minus 1 minus 3 and minus 1 minus of minus plus 1, 6 minus 2 is equal to 0. Now this implies determinant of x minus 3, y plus 1, z minus 2, 5 minus 3 is 2, it is 3, this one is 2, minus 1 minus 3 minus 4, it is 0, and this one is 4 is equal to 0. Now expand the determinant. Expanding the determinant, that is x minus 3 into, deleting the corresponding row and column, 12 minus 0, of course it is 12, minus of y plus 1 into, deleting the corresponding row and column, 2 into 4, 8, 8 plus 8, 16. Okay, next, plus z minus 2 into 0 plus 12, that is 12 is equal to 0. Here you know clearly fourth table cancel. So we can divide this entire equation with 4. So after dividing by 4, it is 3 times of x minus 3, it is minus 4 times of y plus 1, and this is 3 into z minus 2 is equal to 0. Now expand 3x minus 4y plus 3z and minus 9 minus 4 minus 13 minus 13 minus 6 minus 19 is equal to 0. Now this is equation of the plane passing through given 3 points. But the question is, what is the distance of the point P, 6, 5, 9 from the plane? So when the plane is in the form of ax plus by plus cz plus d is equal to 0, then the perpendicular distance or the distance, perpendicular distance or distance of the point P whose coordinates are 6, 5, 9 from the plane is modulus of a into x, that is we can substitute 6 in place of x, 3 into 6 minus 4 into 5 plus 3 into 9 minus 19.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.